Till now in this course we have covered several topics. We talked about oscillations, we talked about two-body problem where we looked at Kepler's problem and other things. Now we will move on to a new topic, which is rigid body dynamics. Okay, and here we are going to start asking very simple things about a rigid body, and that's the plan for this video today. But even before I talk about a rigid body, let me talk about an atom. Okay, I want to ask how many degrees of freedom an atom has. I'm asking this because our rigid bodies are made up of atoms. Okay, so let's ask what are the degrees of freedom of an atom. Okay, now the answer depends on what you mean by an atom. Now if you mean by an atom a structureless thing which has no internal structure, there are no parts to it, then it has 3 degrees of freedom. Okay, all you need to tell is where that guy is located in the space-time, in the space. Okay, so it will have 3 degrees of freedom. But if you want to view your atom as something which is made up of a nucleus and an electron, then the degrees of freedom changes immediately, right? It has more degrees of freedom compared to a structureless thing. But let's say if you want to view your atom as something as an electron and nucleus, as far as nucleus is concerned, you want to allow for more structure to it. That is, you want to tell that nucleus has protons and neutrons, then the degrees of freedom are even more compared to what it would be for just a nucleus and an electron. Okay, you may want to go further and you say, okay, no, it's not just protons, neutrons and electrons. I know further that protons and neutrons are made up of quarks and gluons. Then the degrees of freedom further increases. Okay, so it really depends on what you mean by an atom, which is going to decide how many degrees of freedom that atom has. Okay, so in this while we are talking about rigid bodies, when I say an atom, I mean a structureless quantity which has 3 degrees of freedom. Usually, to be more precise, I would, instead of an atom, I would say a point or a point particle, and all these 3 will mean the same thing. Okay, so for me, when I am saying an atom, it's a structureless thing. Structure of structureless object or a particle, or by a particle you always mean a point like particle. Okay, that's the meaning of a particle. Okay, now whether you should treat your atom as a particle or as something made up of a nucleus and an electron, or something with more details regarding its nuclear structure, depends on what you are looking at. Okay, depends on the scale at which you are doing physics. For example, in some case it may be completely pointless to even think of what the structure of atom is. Okay, so it's really determined by the problem you are looking at. Okay, and you cannot say a priori whether you should look at an atom as point like object or not. Okay, now similar things you can say about a solid. So let's say you are given a solid. Now, how many degrees of freedom does this solid have? Let's say it is made up of n atoms. Okay, now how many degrees of freedom does it have? Well, as I said just now, it will depend on the details, but let's say I start to think of this solid as made up of atoms which are point like, okay, without any structure. Now, how many degrees of freedom does this solid have if it has n such atoms? Well, it still depends on what you want to see about that solid. Let's say you are interested in only throwing it up in air or in space, and you just want to see how it moves around. Okay, if you are interested in only that much, then you can regard your solid as made up of particles or atoms whose distances from each other are fixed. Okay, that is what you can regard it as. But if you are interested in taking up the solid and heating it up, then that description which I just said is not appropriate, because you cannot heat up such a solid. It will not absorb any energy. There is no way you can give energy to such a solid. Okay, I mean, you cannot give energy by heating it up, because there is nothing internal which can change. Okay, so a description of a solid as a set of particles whose distances are fixed is not suitable for studying its properties under thermal exchanges. But if that is not your concern and you just want to ask how it moves around as a whole, then you can consider those distances to be fixed, and you can regard this. Okay, this is not yeah, that's correct, solid. You can regard it as a rigid object. Okay, so by rigid I mean the distances between different particles of the object are not going to change with time, and that is what we mean by rigid. And as I said, this may or may not be suitable for the problem you have at your hand. So let's say we are interested in rigid objects. Okay, the first question we would like to ask is, how many degrees of freedom a rigid body has? Okay, so that's our question. How many degrees of freedom a rigid body has? Okay, there are many ways in which you can do this, and I'm going to do it in the following manner. Now, suppose this is the rigid body which is given to you, the one which is marked here. Okay. Now, the way I'm going to count the degrees of freedom for this rigid body is by building it up from scratch. So I'm going to assemble all the points which are in there. Okay, so this is made up of several points, n points, let's say. Okay, I'm not taking a continuous thing, but I'm taking a discrete thing. So let's say it is made up of n particles, and its distances of these particles from each other are given. Okay, so I'm going to now build this up from scratch, and in doing so I'll count the degrees of freedom. Let's choose any one of these particles which we like. Let's say this one. Okay, now suppose I want this body to be moved to a new location, and I want this point, this particle, okay, to be here. So I have some origin, okay, some system of coordinates, and I bring that particle to here. So I'm imagining taking only one particle and putting it here. So I want this particle to be here. How many degrees of freedom does this have? Meaning, how many numbers I should specify, how many numbers I need to tell where this is located? Of course, 3. So 3 to tell where this guy is. Now let's take any other particle. Let's say this one. Okay, I want to bring it here because I'm building the body. Okay, and this distance is given to me. It's already fixed. Let's say this guy is a distance a away from this one. Let's say this is particle number 1, this is particle number 2. So I have already brought my particle number 1 to the right location. Now I want to bring in the particle 2. Now particle number 2 is at a fixed distance a away from particle number 1. So let me construct a sphere of radius a around particle number 1. So that's my radius a, and we can construct a sphere around this. Let's try doing this. Because I've been drawing ellipse, it is becoming an ellipse instead of a circle. Okay. So this particle number 2 could in principle be anywhere on the surface, okay, of this thing, and it will be still a distance away, and it will still be the part of that rigid body, right? Because all that particle has to do is be away a distance a away from particle number 1, okay, because you can take this body and turn it and move it around, and the location of particle number 2 will change, okay, its orientation will change, but the fact that it is a distance a away from it is not going to change. So it can live anywhere on this surface. So to tell that I want the particle number 2 to be here, I have to specify two things. Okay, remember this is a sphere, not a circle. I have to specify two things. I have to specify two angles which will fix the location of this particle, right? So you have to specify, for example, the theta and phi, the polar and azimuthal angles for in this sphere. So you choose a direction, okay, and if you specify those, then you will have told where this guy is located. Okay, so this is next two. First we had 3 numbers for first particle, then for the particle number 2 I have used up 2 numbers, not used up, but I need 2 numbers to specify where it is. So as far as this body is concerned, right now I know about these 2 particles, okay, but there are a lot of n minus 2 particles still remaining. There are total of n. Okay, now let's look at all these particles which are on this line. Okay, all these particles. How many degrees of freedom is going to be taken up by telling where this particle is or where that one is? Well, nothing. You don't need anything. You don't need any number to specify these, because they all are going to be completely determined where they are just because you have fixed the particle number 1 and 2. I hope that is clear. There is no there is nothing really in your hands. These particles cannot be anywhere else if your particle number 1 and particle number 2 are fixed. They have to be on this line. So let's say this guy was some distance b away from the first particle. This is distance b away from this first particle. It cannot be anywhere else. It has to be on this line a bit distance away. It's fixed. Okay, so there's nothing you need for this. So our degrees of freedom still remain the same as far as all these particles are concerned. So if you draw a line connecting point number 1 and point number 2, then all the particles on that line, okay, they are completely specified, their locations, by specifying these 3 numbers and these 2 numbers. Okay, so 3 plus 2 is 5, and clearly that is the degrees of freedom of a solid line, right? This entire line is completely fixed. All the particles on that line are completely fixed if you specify these 5 numbers. So a line has 5 degrees of freedom. Okay, we are very close. We haven't built up the whole object, but I have at this location now this this line. Okay, this line is same as this line here. These two are same things. Okay, now let's see how much information is required to bring in other points. Now let's take some point here. some distance c away from that line. Okay, and let's see how much freedom this point C has. Now once you have specified this line, that this is the direction in which all these particles are oriented and the point number 1 is here, and you are talking about a particle which is a distance c away from the particle number 1, or let's say from that line. Okay, now if you just tell me that this is let's call it particle number 3. Let's call it particle number 3 and the distance is c. So this is particle number 3. Now this particle number 3, if you tell me only that it is distance c away from this line, then it could be anywhere on the circle whose center lies here, right? See, with this distance fixed, you can draw a circle around this point. Let me try to draw it. Okay, this is a circle which is going into the plane of this your laptop or your screen. Okay, so in principle this particle could be anywhere on the circle and it will still have the same distance c. But if you want to tell that no, I want the particle to be here or there, okay, then you have to tell one angle. Okay, to tell where you are on a circle, you need to specify one angle. Let me call it theta prime, because I have already used up a theta here. Okay, so you need one more number to tell where you are on that circle. Okay, that's nice. So I know how to also bring in this point. Now any other point, do I still have some freedom? Let's say I have fixed, once I have fixed point number 1, point number 2 and point number 3, can I do anything else? Can this point 4 be anywhere else if I have fixed the locations of 1, 2 and 3? And the answer is no, it cannot be anywhere else. It has to be here only, right? And this point has to be here only. These are all fixed now. Now once you have specified the locations of these 3 points, all other points in the rigid body are completely fixed. You are not left with any freedom. Okay, so it means that to specify your rigid body where it is, or equivalently to specify all these endpoints where they are, if they are all rigidly connected, you need to tell me the following numbers. I mean the following these many numbers. So you need 3 to specify the coordinates of first particle, which is 3, then the coordinates of second particle 2, all particles on the line are fixed, then for any third particle, whichever you like, you need one more, that angle on the circle, and there's nothing else left. All particles are completely fixed in space now, and this is 6. So you have 6 degrees of freedom for a rigid body. Okay. Now sometimes it will happen that your rigid body would be let's see what has happened. Just a second. Okay, we are here. Okay, so sometimes you will have your rigid body which will be pivoted. Okay, so there will be a pivot. Let me write this word, P-I-V-O-T. Sometimes things appear more difficult just because the words are unfamiliar, and I remember not knowing this word pivot and being scared of this thing. Okay, so pivot, let me write down the dictionary meaning from Cambridge. I think pivot is a fixed point supporting something that turns or balances. Okay, something like this. A fixed point supporting something. That's sufficient for us. Okay, so imagine, for example, you have let's say how do you say, let's say a top. Okay, and this is its nail, but you fix the nail to be here, it cannot move anywhere from this location. But other than that, the top can do anything. So it can, let's say this axis, this is the axis of the symmetry axis of the top. So this axis can go there, with this point still remaining fixed. The top can turn, all these things it can do, but this always remains here. This point is a pivot. Okay, you may not necessarily have cases where the pivot is like this. You may have a fixed point, okay, somewhere in the body. So you can fix a point somewhere in the body, and then you ask about its motion. Okay, with that point always being there, stationary, that could be a pivot. Okay, it will be again a pivot, or more easily I will just say fixed point. Okay, so for this, of course, you cannot imagine like putting some wire or stand something. That will not, because then it will immediately fix many other points. So you have to just imagine that somehow that point is holding there. Okay, okay, that's fine. Now you may ask, how many degrees of freedom does a rigid body have if it is pivoted? Okay, if it has a fixed point, and clearly it will have 3 degrees of freedom, because you remember when we were talking about when we started building it up, you need 3 degrees of freedom for one point, right? So that is those 3 degrees of freedom that I'm going to take away. Okay, so if it is not immediately clear, you please sit down for a while, and I'm sure you will understand why it has 3 degrees of freedom. So a rigid body with a fixed point has 3 degrees of freedom. Okay, one way to think about this would be, you just imagine your origin to be here, and then run through the argument which I gave for the general case, and you will arrive at 3 degrees of freedom. Okay, so we'll stop here in this video, and we'll continue about this subject in more detail in the next video.